okay?
It's perfect. Thank you.
I'm sitting in an office in the Architectural Association. It's a little bit sort of echoing, but I hope it's okay.
It's okay.
Yeah, I have about 20 minutes to talk about the concept of radical wood tectonics or radical tectonics. And I chose the subtitle, "The Detail is Crucial." And I'll go through a number of different projects and how could you say, questions that are on our minds in our research center, which also made this the reason why Gilbert and Pierre also reached out for us, very much helped by Ulrich Knack to begin with, but that's how it all started. So yeah, radical wood tectonics. I will talk about projects that has been, or ideas that have been dealt with in our research center. We also have tested indirectly with students, and we were very much looking forward to go deeper into this in the workshop in the fall. However, before I start, I just want to make sure that if we know what we're talking about when we're talking about tectonics, not to say that there's one definition, but also to emphasize why it's relevant. We define tectonics from our end as part of architecture. It's not pure technical, it's not aesthetic, but it's like a subdivision of architecture as shown in this figure. So it still sort of includes the three main concepts defined by Vitruvius: the firmitas, the material; venustas, the aesthetics; and the utilitas, the functionality. However, when we speak about tectonics, it's about the material, the form, and the technique, and how these three ends are, or means are sort of ending up, that defines the tectonic. As part of this, we have been working in the center over the years, and one of our former PhD students and now one of the teachers in the program also have defined what we call the alphabet, the Tectonic alphabet. But just to line up the fundamentals, we say that tectonic in architecture defines the correlation between the fundamental architectural idea, the overall idea, the material properties, the form principles, or the anatomy of the full building or the structure, the choice of building technologies, and the structural rules present in the construction. So it's also about specification and designing and joining of materials to form an architectural synthesis. So it holds an architectural ethics and an effective way to direct and control resources in construction. And I think the former lecture just showed that very, very elegantly. So just to show the image on the right, it's just a small brief example of the different or various tectonic principles that could be stacking or layering, weaving, clamping, tensioning, or locking. And why these principles important is also something I'm going to go into more detail with in presenting the projects later. But just to start out, one of the largest problems we are facing these years, everyone is talking about it. Fortunately, it took some years, but I think over the past 5 or 7 years, it really has accelerated. But the ecological crisis worldwide is now calling for profound solutions. So we have to find all different kinds of technologies and ways and ideas that have to be launched in order to help solving some of these problems also mentioned here: the biodiversity, the problem of waste production, and of course the material scarcity, and not the least the greenhouse gas energy supplies has to be rethought. So from our end, it has meant that we have been, in the research center, we have been very much looking at circular principles, or how to apply materials and look into the construction industry from the end of having the material and the value of the materials in the loop, both in the technical loop, the technosphere, as well as the natural loop of resources, the ecosphere. So it's from that end we, in 2017, were part of an exhibition where we were testing some of these ideas about the radical tectonic and how we could apply the tectonic thinking as a way to approach this very sort of strict understanding of materials and the way they were to be included in various structures. So before we did that, we sat down and wrote this manifesto for circular construction, and where we sort of defined a number of rules by which we were going to work. And they're mentioned here as we wanted to minimize the volume and the number of types of materials. We also saw that in the former presentation, how the number of, or the types of materials, the variation can create trouble. We wanted to use uncontaminated or untoxic materials that should not be further treated. And we wanted to apply construction joints that could be disassembled, designed for disassemble. And also we wanted to reduce the waste in production. And this meant that we had to leave out the demand or non-renewable energy in the production. And we had, because you had severe negative environmental impact, materials made from raw oil. And we wanted to leave out the damaging materials to health and humans, animal, or nature per se. So we ended up defining 3 walls. They were thought as generic wall structures in that sense that they were conceived and built according to regular building regulations in Denmark. So we are applying proper materials that sort of perform according to the regulations, and we wanted to use regular standards and building procedures as we meet in the construction industry. However, I'm going to just to talk about the wooden wall due to the theme. As part, well, just before I do that, as part of our initial sort of preparation, we were also defining what we later called the construction material pyramid. The first one we applied for the project was smaller than this and only included the materials that we applied, but then we have developed it into this now larger pyramid with including 60 materials, and it's now digitalized and it's accessible on the web. But in one way, this was also a tool or a way to sort of do the very strict selection of materials by which we could perform in ways that we had to have the lowest possible CO2 emission and the lowest possible energy consumption and the highest possible lifetime or lifespan of the materials, and of course also simplicity in the number and the types of materials with the high focus on the bio-based materials. So as for the wall principles, we tried to stay strict to the industrial standards in that sense, also to omit or limit waste production. We applied regular elements, structural elements, such as a specific OSB board and regular pure wood beam structures that were cut up into regular pieces, and then we made these sort of separate wall elements that could be joined by these clamp details that were added on each of the elements. And what we did, as you see to the right, this is where the Tectonic Alphabet comes in play. That we are using the Tectonic Alphabet as a way to direct and focus the discussion about the various specific technical solutions. And what you see to the very right, you see the technical specifications of how the structure is actually built. So this is the final drawing of how it was actually built. Of course, under construction, there were many different iterations and versions of similar ideas. But as for the Tectonic Alphabet, it sort of helped us to keep on track and also to end up with this final production. So in order to show here the tectonic principles, it was the materials used were stainless steel, solid wood, and boards made from wood without formaldehyde. We wanted to keep the toxic level very low. And as mentioned, we used the standard sizes of the OSB and had determined that the wall elements and dimensions were to avoid waste from assembly. And also the standardized dimension of the elements were limited to the need of cutting the solid wood components. So we only had very, very few cutting procedures. Yeah, so in total, we could say that we wanted to keep the elements at a very high level in terms of design and also the element or the component itself. So it also could be both disassembled, but also reapplied in the full scale. We'd also try to mimic the processes of, you could say that could be translated into an industrialized process by very, very few procedures, and that the elements had to go through, how could you say, similar structural features. And here we see the steel brace that joins the elements, which also becomes sort of an ornament defining the wall surface, and also holding the two elements together across a cork plate or membrane. So as for a life cycle scenario, we tried to see or at least estimate how would these different materials, how could they be reapplied over the years, and we have here the different sort of life cycles depending on the very material itself, and of course the screws and the fittings are maybe the ones that would have the longest lifetime, whereas the boards and the wooden the solid wood would have a different, a shorter lifetime. The other example, because the one I just showed was, of course, if we apply new or fresh wood, whereas this example I'm going to show here with whom we have been working closely over the years, Nordic, who's now working for Aslan Viak, she did a PhD project almost 8 years ago, where she looked into what she called salvaged architecture or salvaged materials in architecture. And she developed what she calls the Staune timber block based on waste wood from demolition. What she did here was actually she took wooden boards, mostly floorboards, and cut it into smaller pieces. And then made these, you could call them wooden blocks that could be stacked on top of one another, and the boards would be held together with dried wooden nails, you could call them. So they would be dried in the oven and hammered through the block. And when it would be expanded, when exposed to humidity, regular humidity, it would hold the block together. So she made this sort of new, you could call it a wooden brick or a wooden block that could be stacked for various wall structures. And here we see one of the prototypes in which she tested the system. It was also an idea she wanted to apply using unskilled labor to do these or to make these fabricate these small blocks for later use in industry. She has now tested it in a small prototype, so she sort of keeps on developing the idea further. It hasn't yet been tested in a full structure, but only in small pavilions like this. However, she has been involved in a project also together with a colleague of ours who's one of our teachers, the Nordic Build project called, I can't see the title here on my screen, but the new Nordic wooden block. And it's also based on this waste wood product. In this, they tried to develop it for regular structures. However, it's only secondary structures because it has problems with you could call the statics of the structural element. So it's so they claim here that it's the massive waste wood component, which is the building material of tomorrow. So they what they were concentrating on in developing this component further was that it had to be module based, small medium size, that you could handle it 1 or 2 persons, and it also had to be based on very low or medium advanced technologies, and finally it had to be produced locally. So what can we learn from this across the various ideas and projects, and where do we have to get started also for the launch of this workshop in September? We would definitely recommend that you choose an overall strategy, what to focus on, maybe write a manifesto. It was very helpful to us. And you have to define the principles by which design rules and fabrication methods you work to make it feasible. And finally, of course, cherish the world of details. Use your fantasy and draw and test and model one-to-one. That's something which has really been a great world for us to dig into.